Hello and welcome to lesson 1 of the Coasts at A-Level series. This video, like the others, will be split into 5 sections, and I'll start by explaining the Coasts module and video format, and then we'll move on to some brief introductory content. So let's get started. So this lesson, as with most geography videos and content, will draw heavily from the Edexcel specification. A link for that will be added into the description, and I will also be following the structure from these 2 revision guides that I'll also be referring to in the description. So, what is a coast? What is the first thing that comes to your mind when you imagine coasts? Is it a sandy beach? Is it a shingle beach? Perhaps it's even the iconic cliffs of Dover. These are the most common thoughts when people imagine coasts, but there are also things like saltwater marshes, there's man-made ports, and there's also islands, all of which also count as a coast. They all have unique coastal landforms. Now, most exam boards, including the Edexcel exam board, assume that A-level geography students will have prior knowledge on coasts from GCSE level. However, I know not everyone that does A-level geography has done anything previously, so I'll try to make these videos as inclusive as possible and assume no prior knowledge. If there is a topic that is of concern to you, you can drop it in the comments below and I can upload any sort of information or even a video on it if needs be. But these are the generic sort of things from the specification that they assume you will already have knowledge of. So, moving on to the content, the first important part of the content is this thing called a littoral zone. And the way in which I remembered this when I was doing my A-levels was to say that the littoral zone is quite literally the boundary between land and sea, and it is where waves start to interact with the seabed up to the point of the highest storm tides. So it's essentially just anywhere where you can see land and sea in the same space. Now, if I highlight anything throughout this video, it means that it's kind of an important word or term that the exam board will be expecting to see used, especially in your answers for exams, and it shows understanding. So the littoral zone is a dynamic zone, which means that it's constantly changing, and it's a distinctive landscape, which means it's unique, as it has processes from marine, which is in the sea, and terrestrial, which is on land, and where they both meet each other and combine. So you've got marine erosion and on-land weathering all in the same space, and that doesn't happen anywhere else. So that's what it means by it's a distinctive landscape. And this diagram below is a 3D view of the previous diagram of the littoral zone. So in this introductory video, this brief introduction to coasts, we are going to look at classifying coasts, and I've split it into 4 fairly simplistic methods of classification, but the revision guides have pointed out that there are many more different versions of this, like primary and secondary, and there's more like scientific sort of stuff, but I've just gone for the 4 pretty basic ways of classifying the coasts just to get started. And this first one is what's called a concordant coast, and it sounds really scientific and really quite difficult to get your head around, but it essentially just means how the rocks are stacked within the earth and the direction of which these rock layers face the sea and oncoming waves. So a concordant coast just means that there is one layer in contact with the sea at all times. And in most cases, due to erosion, concordant coasts are the ones where it's just an igneous rock layer that's protecting the other less resistant layers. This doesn't mean to say that the igneous rock layer doesn't erode, just that it takes thousands of years to erode significantly. So the cliffs of Dover, for instance, would be an example of a concordant coast, obviously not with an igneous rock, because it's chalk, but that is just one rock layer the whole way across. Okay? So if we're to look at a discordant coast, this is when all the layers are exposed to the oncoming sea and are eroded at different rates due to lithology, but we'll go into that shortly, what lithology means. But essentially, this is erosion at different points, And as you can see, I've tried to draw on how the erosion would differ with each layer. And you get the creation of headlands where the land sticks out due to it not eroding as fast as the middle bit, which is the mudstone layer. And then that mudstone layer will become a bay. You see a lot of these sorts of discordant coastlines along the coast of Devon with various bays and headlands. So that's that. That's those two. But it can also be both. So it can also have a concordant and a discordant attacking the same part of land. You see this most easily with islands. So imagine that square where the igneous, mudstone and sedimentary is just one island. And this is how islands and landforms take shape due to this sort of erosion. So another way to classify coasts is with high and low energy. With a high energy coast, it's important to mention fetch. So this is the distance that the wind can travel without hitting anything before touching the coast, and how it carries waves. Because remember, waves are created by friction between the wind and the water, and they move waves towards the land. So the more wind you have, the bigger the waves you'll have. And the UK and Ireland coastlines exposed to the open expanse of the North Atlantic Ocean will experience the most storm conditions and high energy waves. It's also why people like to go surfing in these locations that I've tried to highlight with red, because of the fact that the waves are highest at these points. It's an oversimplified view, but these are the most common. And the prevailing wind, which means the most common wind direction, pushes the waves in the direction of the arrow. So if we were to look at a low energy coasts, so low energy coasts have calmer sea conditions and are often sheltered by headlands and spits. The Wash is a good example of how low energy coasts are created and protected, as it has two headlands and a spit, as well as being the location for various river mouths that deposit a lot of sand, rocks and sediment, further dampen the energy of incoming waves. The waves not being that violent anyway on the east coast of the UK, because there's not enough fetch for the waves to get that energy. The third way in which I've classified coasts is by geology. I will look at this in greater detail in lesson 2, but for now I'll just explain these brief points. Because geology is so broad, it is probably better to refer to it as geological structure in an exam answer, and that's what I'm going to refer to it as throughout these videos. And that is basically just your concordant and discordant coastlines. It's all about how the rocks are laid out in the earth. That is the geological structure of the earth. Lithology, however, is more about the characteristics of the rock itself. Important note here that during GCSE Geography and Science, rocks may have been referred to as hard and soft, but at A-level we really need to be saying more or less resistant to erosion, because no rock is soft. But this is where you have your 3 rock types. I've only gone for these 3 because these are the most common that you find at a coast. So you've got your igneous rock, which is the most resistant to erosion. This is 1 millimeters of erosion per year, give or take. The sedimentary rock is all different sorts of rocks and shells all clumped together. This is an average sort of resistance, give or take, depending on where you're looking. So you've got 1 to 4 centimeters this time of erosion per year. And then you've got mud rock, which isn't technically a rock, it is just clumps of solidified mud. And this is the least resistant. This is 1 meter of erosion per year, depending on how exposed it is to that erosion. So the last one is the impact of rivers. This is all to do with accretion and how when a river drops all the sediment it has been carrying, the sediment builds up to create a natural wall against waves. So if you see in the photo, the murky water shows where the sediment has been building up over time, and the mouth of the river creating this sort of salt marsh and muddy beach sort of environment that is perfect for stopping waves, because that's the first thing the wave will hit before it hits any of the rocks mentioned in the geology part. So you may end up with a question in the exam that talks about issues associated with classifying coasts. And the Valentin classification, as scary as it looks here, sorry for the bad image, but this is the only one I could find that's actually got like numbers on it to kind of show you that it's a measurement and not just a model. And it's just an example of how measuring coastal processes is not entirely straightforward. With this model, you essentially measure everything about a small stretch of coastline, from how much it's eroded or expanded to the height it has shrunken or grown due to the isostatic rebound. But we'll look at all these things later on in other videos. The overarching message behind showing this model is that measuring coastal processes can be too simplistic and oversimplified to cast aspersions about an entire coastline, an entire stretch of coastline, just from measuring one small part of it. So that would be the main sort of answer to why classifying coasts is somewhat problematic and challenging. I hope you found this video useful in introducing you to the Coast A-Level topic. If you did, be sure to like and subscribe to show your support to the channel, and I just want to thank you all for watching.